Hello there, this is Vasudev here again, product planner for power solutions in the Tektronix Core product line. Today we are going to talk about power supply rejection ratio, an important parameter of qualifying how good the DC-DC converter is. Basically, power supply rejection ratio looks at how good the converter, the DC-DC converter, rejects the AC ripple going out. Theoretically it should be zero, but practically we all know there will be a small amount of AC ripple going out. Here we have used a MSO 5 or 6 series with built-in AFG or an external AFG. We use the commercial available injection transformer, in this case an Picotest J2120A injection transformer is used. A typical setup, as you can see here, the oscilloscope is now converted into a frequency response analyzer, particularly power supply rejection ratio measurement analysis tool. We use the TPP0502 probes, the recommended probes for the frequency response analysis. The modulated AC plus DC signal is fed into the demo board here from Picotest, and we are capturing both the input and the output AC ripple components to calculate the rejection ratio. The injection transformer, the J2120A, is very much suited as it combines the DC and the AFG input, AC plus DC, to be fed and is powered by the Keithley power supply. The output of the 5 or 6 series MSO optional AFG output is fed into through the injection transformer to the DUT, and on the power measurement tab we have the PSRR, and the capabilities are exactly the same as we saw in the control loop response. You can have the start-stop frequencies and get the entire process done automatically. The software takes control of it. As the sweep happens from the start frequency to stop frequency, based on the amplitude you have set, the oscilloscope is now converted into a PSRR measurement capable solution with the x-axis as frequency and the y-axis as the rejection ratio of input ripple to output ripple. So as it sweeps, the software plots the minimum and maximum values of the power supply rejection ratio. You get to see how good your DC-DC converter performance is and make changes to the design, as you can now also see the waveforms, the analog waveforms that is going into your DC-DC converter, both the modulated input signal of AC-DC and the output of your DC-DC converter. The results table gives you the ability to look at all the details at various frequencies and the rejection ratios at each of those frequency points. And with the cursors enabled, you can now see what the rejection values were at a specific frequency. All of this can be saved into a report format in HTML or PDF format. And you can see all the details there, including the results table and the plots captured. Make it an effective, complete one-box solution tool for power design engineers. So the new measurement, power supply rejection ratio, is a good measurement for DC-DC converter qualification. And in summary, we have got a one-box solution with the built-in AFG or an external AFG 31000 series using the commercially available injection transformers.
Find out more at Vicom's website.